Hi, everybody, and hope you guys all had a wonderful weekend. So, for this lecture video, we're going to continue to review our final exams. That's why I put it here is the final exams number 2. So, we will start with the problem number 8 here. So, this is the finance problem about finding the interest rate and find the interest based on certain interest rate here, okay? So in here, we want to find the amount of the interest, okay? And earned by the, if you deposit 30,000 at a 5% annual rate for 8 years. So the first thing here is how much interest if if I use by doing the simple interest. So let's take a look. So part A. So for the simple interest, the formulas here is pretty straightforward. That means you just use the principal times the interest rate and times the time. So the interest will be equal to the P times the R. R is the annual interest rate, and times the T, PRT. And so this will be 30,000 times 0.05 and times 8, right? So this will be the 30,000 times 0.05 times 8. So it will be 12,000. So at the end of the 8 years, you will get the interest at 12,000. Okay, so now if I want to do compounding annually, so compounding annually, instead of using the formula, of course, you can use the formula, or you can use the TI-84. So I'm going to show you how to use the TI-84 to do it. So I'm going to leave the whiteboard and go to the and go to the TI calculator. Okay, so here we go. Okay, so you turn that on, clear that out, clear that out. Okay, so we did this in class before, so you do apps here, then you do a finance, then you TVM. So in here, we say 8 years, right? So you put 8 years, and the percent of the interest rate, you don't put the 0.05 because they already have a percent here, right? And let me clear this out so we know what to input, right? Okay. Okay, so here, okay, so first here, N is the number of the years, and the I is interest rate. Present value is how much you deposit right now because it is out, you take out your pocket. So in here, 30,000, you put a negative here, you put a negative 30,000. And then you say, you're compounding annually. That means every year you're compounding once here, right? So it's 1. Okay, now you here, then you want to find is your future value. So you put your cursor here, the future value. Then you do the alpha solve. So it's 44323. Okay, so this, so you will get your future value is 44323.66, right? So 44323.6, that's your future values here. Let me leave here and go back to my whiteboard. Okay, so if this is a compounding annually, so your future value is 44323. So your interest will be your future value minus how much you deposited, right? So this will be 44323.66 cents. How much you deposited in the beginning? 30,000. So that's why you will get your interest of around $14,323.66. Right? So you use your future value minus your present value. That means minus how much you deposit. So this extra money you're going to get at the end of 8 years. That's why, it's your interest, okay? So now let's take a look. So how about if, that if my interest is calculated quarterly here, so I'm going to switch back to my calculator again, okay? So I'm leaving the whiteboard. Okay, so in here, okay, so let's quit here, then clear. Then I do the app again, finance, right? So TVM, so let's clear out. So here, okay, so now it's a compounding quarterly. So you still have 10 years, you still have 8 years. Your interest rate still is 5%. You still deposit 30,000. That means you still take out your pocket, so it's negative. And let me clear out these future values. Okay, and then you do payments one. But now, how frequently you compounding? You compounding quarterly, right? So you're compounding quarterly, so this is 4. Now you're going to find your future value. So you use the alpha solve. So it's your future values here is 44643.92. Okay, so now let's go back to my. Okay, so here, share the screen, go back to my whiteboard. Okay, so your interest here, because your calculator just gave you the future value is 44643.92 minus 30,000. So that's how much is your interest. It will be 14,643.92. Okay, so now the last one's here. How about if I want to compounding continuously? Unfortunately, we don't have, we don't have the TI-84 doesn't have the selection for the continuously under their finance apps here. So we need to do that. Okay, so the future values here is what we have, we call it the PERT, right? So it's PERT. So E is that natural number is 2.7182, right? So it's that number you can find in your calculator. So now I can just put my P, what is P? P is the principal. So this is 30,000 times the E, then 0.05. How many years? 8 years, right? That's 8 years. Now, let's put it into the calculator to see what you have here. So it's E to the 0.05 times 8, then times 30,000. So you will get a 44754. So it's a 44754.74 here, right? Okay, so now the same way, the interest will just be your future value minus your principal. So future value is 44754.74 minus 30,000. Okay. And this will be 14,755.74. That is the Sorry, that's my dog playing the toys. I need to go to get that toys away so it doesn't make so much noise. Hold on 1 minute. Mom, that's too loud. Okay, I'm back. Sorry. She loves that squeegee toys. You know, it's always making noise. Okay, so now that is how do we find the interest, right? And like we talk about, you know, if you are compounding in a certain time period, you can use the TI-84. If it's not, you know, if it's compounding continuously, you need to use this formula, future value is PERT, right? P-E-R-T, see, all right? Okay, let's take a look on problem number 9 here. Okay, problem number 9. So this is an annuity. Annuity is we can use the, you know, the TI-84 calculator also. So find the future value of the following annuity. Okay, so part A here is deposit $1,300 at the end of each year for 10 years, right? At the end of years and for 10 years. And the interest rate is, the R is 5% again. So I want to find the future values here. Okay, so now let's take a look. Let me go into, leave the whiteboard and go to my calculator now. Okay, so here, let's clear that out. Let's quit and clear that out. So, okay, so in here you go to the apps. Okay, so now TVM, then clear that out. Okay, so now the TVMs here is I'm going to have 10 years, right? Interest rate is 5. And then in here, it's not the present value anymore. It's not I deposit one time, I have a payment. So now these payments here, these ones here will be what? This payments is you get out of your pocket 1,300 every year, right? So you put a negative 1,300, then clear out the future values, and you do a payment once a year, right? Because at the end of each year here, then you're only compounding once a year here, right? So compounding annually, if you read the problems here. And then now the keyword here is end, right? So here, let's see how much my future value will be. So I do alpha solve. So the future value is 16351.26. Okay, since we are in here, now we can do the part B. And the part B said is the beginning. Okay, so let's clear this one out. Then let's go down here. Instead of end, let's set the beginnings here. Then let's go back to the future value. And then let's calculate again. So it's 17168. So it's 17168.8231. Okay, so now we can leave the calculator and go back to my whiteboard. Okay, so for here, the future values, if you deposit at the end of the year, it will be 16,351.26. Then part B is the same thing. You deposit 1,300 at the beginning. Right, so the key part here, keyword here is the beginning, and this is the end. Then all the others is the same. So here for 10 years, so this is the same. Then your future value, we just calculate. I hope you wrote that one down. Is 17168.82 cents here. Okay, so that's number 10 here. Number 9 here. Okay. And now let's take a look at number 10. I like to go to a new page because number 10, I might need bigger spaces here. Okay. So this is number 10. So number 10, I tell you a jar contains 5 colors: red, purple, yellow, green, and black. Okay. A second jar contains 3 colored numbers. So one red, 2 yellow, and 3 black. So what that means here is this is a jar number 1 here. I have 5 color balls here, right? So I have red, so I have a red ball here. And I have a purple ball. I have a purple ball here. And I have a yellow ball. I have a yellow ball here. I have a green ball. I have a green ball here. Now I have a black ball, right? So I have a black ball here. Now my second jar here, I have 3 numbers. Okay, so the first number is number 1, but it is in the red color. So the number 1 is in the red colors here. Then I have a second number is number 2, but the number 2 is in the yellow colors here. Then number 3 is here. I have 3, so it's in the black colors here. All right. So experiment will consider take 1 ball from the first jar and take the 1 ball from the second jar. Okay. So now first things here, I want to ask to write out the sample space here, right? Okay. So the sample space, try to, okay. Try to color coding that. Hopefully I can try. So this is the red ball. I have 1. Now I have a red ball, and I have a red ball. So now I have a red ball. I can take the color 2. I have a red ball. I can take the color number 3 here, right? Okay. Now I have a blue ball here, right? So the blue ball, I can take a. So this is a blue ball. Oh, that's a yellow ball. I'm sorry. This is a yellow ball. Okay, so I better. Okay. All right. So here, so but a yellow ball, and I have a yellow ball. I have a yellow ball. Okay. Then my numbers here, I could have a yellow ball with a red number 1, yellow ball with yellow number 2. And the yellow ball with black number 3 here, right? So that is my yellow. Then I can have a purple, right? So I can have a purple. So it's a purple. Okay, so purple ball, I can have a purple ball with red 1. I have a purple ball with yellow number. I have a purple ball with black numbers here, right? Now I have a green. So I can have a green. So this is a green, green, and the greens here, right? So I can have a green ball with red number 1. I have a green ball with yellow number 2. I have a green ball with black number 3 here. Now the last ones here, I can have a black, right? So this is black. Okay, so I can have a black ball with red number 1. I have a black ball with yellow number 2. I can have a black ball with black ball number 3 here, right? So this is the all this 18 is my sample space here. Okay, so now the B here, they said A is defined the ball color match the number color. Okay, so A, that means the ball color match the number color. So I know this one match, right? The red and the red number 1, right? Now what is the other one match? The other one match is yellow match number 2, see here. So what is the other one match? It's a black match the number 3, right? So this is my event A. And now event B is here, okay? So let's see what is the event B is here. Event B is defined to have an odd number. Okay, event B is have an odd number. So let's try to write it. Event B, I have a R1, then I have R what? I have R3, right? And then the odd number, then the next ones here, I have a yellow 1 and yellow 1 and yellow 3s, right? And then I have a purple, right? So I have a purple 1 and the purple 3s, right? So I have a purple 1 and I have a purple 3. And now I have a green. I have a green 1 and a green 3s, right? So this one will be green 1 and this will be green 3. And the last one here is black. So I'm going to have a black 1 and a black 3s, right? Black 1 and a black 3. Okay, so this is my event B. So that means all the number ball you have has to be odd numbers here. Okay, so now I'm finding, okay, so finding the PAs here, probability of the A. So total I have a 15, the sample space, right? So A, how many elements I have? 3. So this is 1/5. Okay, so now I'm going to find the PB here. So it's the same way. So PB, total how many? I have a 15. So how many I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10. So this is 2/3. Okay, now the other ones here, I'm going to find A intersect B. So what is the A intersect B? The first things I need to find, what is A intersect B? What is this event? A intersect B, that means the common terms here, right? So let's see which one we have a common terms here. Oh, this one, this is a common term. It's B3, this is B3, right? So the intersect B, I have B3. Any other? Oh yeah, this one's here, R1 and R1's here, right? So I have R1. So A intercept has 2 elements. That's why the probability of A intersect B, it will be what? 2 over what? 15 here, okay? So it's pretty straightforward, and you just need to be careful when you try to list the sample space, and when you try to list the events, just be very careful for that. Okay, let's go to the next one. The next one is problem number 11. Okay, a survey of Richmond's students' political view was asked to describe liberal, moderate, and conservative. Results are summarized in these tables here. So here I have a 35 and a 50, and this is a 36, 44, and the 6, 21, and this is a total. So this is a 77, 115. So total I surveyed 192 students. So this is 85, and this is 80, this is 27. So here's the gender. This is the female and the male, and the liberal, moderate, and conservatives. Okay. Okay, so first things here, they ask you, what percent of the Richmond students is male? So what percent of the student is male, right? And so you see here, from these samples here, the male is 115, The total is 192. So this is 115, 192. Right? If you want to simplify, you can simplify if you know, or you can just leave like this. Okay, so now let's see here. Okay, so the second part is pretty easy, right? Because the 115 is here, right? So this is the male, right? So this is the male. 115. Okay, so then the part B is here. They ask you, say, hey, what's percent of the students consider them is conservative? So the conservative is which column here? Is this columns here, right? So this column is all conservative. So what is the total conservative? So I have 27 out of the 192, and those are thinking themselves is conservative. So it's 27 divided by 192. And if you want, you can simplify it a little bit, or you can leave the answer like that. So it's 9/64, right? Or if you want to change the decimal, this will be 0.141, something like that. Okay, so now let's see part C here. The part C is what percent of the male in the Richland think about themselves to be conservative. So okay, so the what percent of the male, all right? So that means you are concentrated on here. Here is my male population from this sample, right? What percent of the male consider themselves to be conservative? So out of the 115, how many males here conservative? 21 here, right? So that's why the probability is here. So that means conservative, given that it is males, right? So under that, so how many males, right? So the what is your denominator right now is 115, and this is 21 here, okay? And now the part D is here, right? The part D is what is the percent of the Richland student is male with the conservative view? That means it's male and conservative, right? So I know the male and the conservative is 21, and out of what? 192. So be very careful about how the problem asks you the question from the part C and the part D. Part C says for given males, right? How they think about their conservatives here. All right, so be very careful about that. Okay, so now let's go to the problem number. Next problem here is number 12 here. Okay, so the number 12. All right, so for number 12, they give you is the probability of the A is equal to 3/4. Probability of the B is equal to 2/5. And they tell you A and the B, they are independent. So remember what is independent? That means it doesn't matter you give me the condition A or not. If B going to happen, it's going to happen. So when one event happen or not will not affect what happened to the other events. That means they are independent behavior. Okay, so now let's take a look here, right? So this is interesting one here. So probability of the A given B. Okay, probability of the A given B. That means under the condition B happen first, what is A? But we just said they are independent. I don't care B happen or not. If I'm going to happen, I'm going to happen. right? So the B does not really count because, why? Because it's independence here. So from here to here is because the A and the B, right? So A and the B, they are what? Independent. It does not matter. You have this condition or not. So that's why the part A, the answer is pretty easy. It's 3/4, right? Okay, so now the part B, they want to find the probability A union B. I'm going to, let's try to refresh some of our formulas here. Okay, so we said if A and B, they are independent, we have a few things, right? So that means A intersect B, it will be equal to probability of the A times the probability of the B, okay? And also we have, we call this addition rule. Addition rule really don't care is independent or not, but here, these two kind of sing together. The addition rule, that means A union B is equal to the probability of the A plus probability of the B minus the probability of the A intersect the B's here. That's what we call addition rule. Okay, so now like in here, this will be probability of the A. So let's write it down, see here. Okay, so this one's here, this will be probability of the A plus the probability of the B minus the probability of the A intersect the B. So A is 3/4. B is 2/5. And since A and B, they are independent, so the intersections will be just you times these two is 3/4 times 2/5 because of they are independent. So now you can do a little bit, so try to find the common denominators, right? So the common denominator will be 20. So this is a 15 plus A minus 6. So it will be 17/20. Did I do right? So it's 5 plus A minus 6. Yeah, so the A intersect B is, A union B is 17/. So now the next one is here is the probability A complement intersect B complement. When we do this type of the problem, it probably is easier. You do a graphs here, okay? So you do a Venn diagram. This is your A, this is your B here. I'm going to use different color so you'll be able to see. A complement, I'm using the yellow. That means everything outside A's, right? Okay, then B complement, I'm going to use here. That means everything outside B's, right? Everything outside B. All right. Okay, now you want to find the intersection. So intersection will be what? Will be the common part, my yellow and the green. So if you take a look at the intersection, will be this part, the purple part. Right, those are the common part between the yellow and the greens, right? So that's what will be my purple part. So the way, then you look at the purple part, you say, oh, purple part is just the outside A union B. So I just figured out A union B is 17/20. So this one will just be 1 minus 17/20. So it's 3/20. Because that the purple part is just everything outside, right? So it's just everything outside the units here. So that's why this is pretty cool problems here, because you need to kind of graph it. Okay, so let's take a look at number 13 here. Okay, so number 13, they tell you a wild biology examined the frog with a certain genetic trait. He suspected may be linked to sensitivity to industrial toxins in the environment. Previous research had established that this trait is usually found in 1 every 10 frogs. He collected, examined 20. So that means in here, he collected 20. The probability to get a trait, this special trait, is 1 out of 10. So it's 1 out of 10 here. Now, if the frequency of trait does not change, what is the probability? So first one here, what is the probability get at least 1? So we know this experiment is what we call this the binomial distributions, right? So that's what we did. We learned before from last test here. This is what we know is a binomial distribution. So at least 1, that means it could be 1, 2, 3, 4, 5, all the way till 20. So like we use this a lot. We say, hey, as soon as you see the at least 1, what you need to do, the easy way to do it is will be 1 minus the probability is none, right? That means 0. So you can say it's 1 minus is x equal to 0s here, right? Okay, so now I'm going to go to the TI calculator and show you how to do that. I'm leaving the whiteboard here. I'm going to the TI calculator. Okay, so here, turn that on and quit this and clear. Okay, so I'm going to the second DISTR. Okay, because this is a binomial, you go down to the binomial here. So you choose the binomial PDF. Okay, so here's the PDF. The number of the trials, you have 20 frogs. And what is the probability here? 1 over 10, right? 1 divided by 10, or you can input 0.1. And now I'm finding the x value is 0. That means none, right? So let's see how much what I have here. So it's a 0.12157. 0.12157. 7, okay? So now, because it's 1 minus p equal to 0, right? So then you say 1 minus whatever the answers I got here. So it's the second answer. So you will get is 0.87842. 0.87842, all right? So now let's go back to my whiteboard here. Okay, so that will be, so this one's here be 1 minus 0.1215 something. So use the, this is how do I use the TI-84 calculators, right? So this will give me 0.87842, something like that, okay? Okay. Okay, now part B is here. They say, what is the probability you will get 4 frogs with this trait? So that means you are finding the probability x equal to 4, right? So now let's go back to my calculator again. I'm leaving the whiteboard. I'm going back to my calculator. Okay, so clear. So let's try one more time to see if we can get that. So you do a second DISTR, right? And you're going down to what? Binomial PDF. So your trial still 20, your P still is 1 over 10. Now your X value is 4, right? And then you do a calculations. So what is going to give you? 0.08978, right? Okay. So that's how. So I'm going to leave here and going back to my whiteboard. So this answers here is 0.08978, right? So let's have also from here to here, you use the TI-84 calculator. So what is the function you use? You use the second DISTR. Then you go to the binomial PDF, right? Okay, so you go to here. That's how did you find it. Okay, let's take a look at one last problem for this lecture video. Then we can quit here so you don't overwhelm by so many problems, and then we can do another one. Okay, so a school fundraising event, a raffle offer, first prize is 40,000, two second prize is 1,500 each, and three third prize. So a ticket costs $100 and 1,000 tickets are sold. You decide to buy, okay, one ticket. Okay, so let's see. This is also very kind of practical problems here. So we say this is X, this is PX here. Okay, the first price you will have is 40,000, right? And this is one out of the 1,000 ticket. So the chance to get it is only one out of 1,000. Second price is 1,500. How many tickets they sell? Two second prizes. So the chance is 2 to the 1,000. Then the third prize is 500 here. And how many third prize tickets there? 3. So it's 3, 1,000. So you paid $100, right? So let's see, what do I expect to get here, right? So you expect to win will be 40,000 times 1/1,000 plus 1,500 times 2/1,000 plus 500 times 3/1,000. All right, so let's take a look at what we have is 40,000 plus 3,000 plus 1,500 divided by 1,000. So it's 44.5. So you expect 44.5. But how much you pay to buy? Well, you pay $100. So it's 44.5 minus 100, right? So when you minus 100, so that will be negative 55.5. So that is your payback, right? So that is, so you are losing. So this is your losing like $55.50, okay? Okay. So they said for this fundraising here, this is a part A here. So if this is a part B here. So for this fundraising, school want to be able to raise the 50,000. Will school achieve this goal with current raffle plans here? Okay, so they want to receive 50,000. So if I sell all the 10,000, 1,000 ticket, right? So each ticket is $100. This is the total how much I'm going to have. Then I'm going to minus out, I'm going to give away the 40,000. I'm going to give away 3,000 for the second prize. I'm going to give away 1,500 for the third prize. So let's take a look at what I have here. So it's 1,000 times 100. Then I minus 40,000. Then I minus 3,000. I minus 1,500. So I got a 555. So yeah, so this is greater than 50,000 here. So I know with the current raffle plan, if I can sell all the 1,000 tickets, then yes, I'm going to meet the goal for my fundraisings here. Okay. Okay, now let's, right now this is a good place to stop. Our next videos, we're going to continue finish the rest of this final exam. Will just be in the chapter 10 part, the algebra part, the different functions here, all right? So make sure study hard for the final exams, and like I mentioned before, the final exam is extremely important, right? Because the percentage-wise has a heavier weight than the midterm. Also, if you bound one of the midterm exam, you can use the final exam to replace your lowest the midterm exams, right? So that's very important. So make sure you study hard, all right? So it's nice to talk to you again, and hope you enjoyed this video. Okay, so nice to talk to you, and I talk to you later for another one to wrap up the final exam, okay? Bye.